Dr. Kim's here. So, 1 mark. It's actually definitely not worth 1 mark. Should be worth 2 marks or at least. Now notice I didn't write W1, U1, Z, W2, U2. I just wrote the points because you want to label those complex numbers on the actual vector line. Okay? So let's have a look at the question. We need to... Oh, this is tough. All right, so W1 is actually this. So this is the part they don't give you the diagram. So that's W1, okay? So that's the point. But yeah, I don't like the way they draw the diagram, so that's the first thing you want to do. So prove that is equal to U1 is this. And what else do they have? Z is that. So Z. Okay. Yeah, so prove that line is basically that. Okay. Right, so what the first thing you want to look at, well, you want to get to this. So pretend we didn't know that, right? So basically you want to get that. Okay? So if I want to get this from here, as you can see, it's 90 degrees. So that's multiplying this by I, yeah? Now, head minus tail is going to be, we're going to be using this to do this question. So if I want that vector, what will it be in terms of the complex numbers? Yeah, head minus tail, so yeah, U1. And then to get to B1 from here, as you can see, that's this. So we already got this bit, okay? And then to get this vector, let me draw it out separately. This, okay? So using vector addition, how would I express W1? So does it work out? Okay, yeah, so W1 is equal to that. Oh, so that's just the answer. So as you can see, it's not as difficult if you just know what to look at. Yeah, that's the first question. But yeah, the tricky part is actually labeling the vectors of the complex numbers. So that's why I don't like it when they do this, because it's like, what? B1 is a point. The one next to it is the actual vector, which they don't give you, so you need to draw that yourself. We need to do basically the same thing for the second part. All right? Find the locus of the midpoint B1, B2 as P. Now, when you just hear the word locus, don't worry about it. Just look at, they just want you to find midpoint of B1, B2, okay? So, i.e., find, oh, my ink is running out. Hope you can read that. Get the complex numbers representing B1 and B2 because we can get the coordinates. So let's do that. Luckily though, we already have one of them. B1, that's W1, but in terms of the coordinate, that is the actual coordinate. How so? Because this is the real part, as you can see, and this is the imaginary part. So yeah, this is the type of things that students don't notice because it's all in letters, no numbers. So the actual coordinate, if I was to write it down, would be U1 and so that would be like, yeah, your coordinate of B1 if you were to put it as a coordinate. So we just need to find B2, all right? So let's draw the vectors out. So we got this, and that's U2, and B2 is W2. So we want to get to W2. So that means I need this, okay? Because that gives me to B2. But what's that way multiplying by 90 degrees? Minus I, the opposite direction, yeah? So we need, so what did we, let's do the same thing here. What did we do here? Head minus tail. So using head minus tail again, what is this? P, remember, in terms of complex number is Z. So head minus tail in this would be Z minus U2. Yep. Z minus U2. Right? So we've done that, and then we're going to do the same thing. That's what we've done there. So we're looking at now this triangle here. So does it work out? Northeast, northeast, yep. So W2 is equal to U2, that. Okay, so once you've got that set up, so the coordinate is, so once again, that's real, because remember, we're trying to find the midpoint now. That's imaginary. So the coordinate is U2. Okay, is that correct so far? All good? All right, so putting it together, U1 plus U2. Then we've got Z minus U1 plus minus Z plus U2. Oh, and the thing here, this cancels out. So the locus is, so you just write that U1 plus U2 over 2 plus, and then that's just the imaginary part. Yeah, so basically, I guess what that's saying is as this point moves around anywhere, the distance between B1 and B2 will be always in that form. Because remember, U1 and U2 are vectors. So the relative distance and midpoint between B1 and B2 will be always in that set as P moves. So we got the complex numbers 0, U, and V forms the vertices of an equilateral triangle, the Argand diagram. So when you see that, you want to draw a diagram. So here's an example of what you could draw out of that. You've got 0, U and V. It doesn't matter which quadrant, but remember, keeping in mind it's an equilateral triangle. So you want to make, remember, that angle to be about 60 degrees, pi over 3, okay? So it helps you just have a diagram, even if they don't give you one. Yes, so as you can see, they haven't given you anything else besides, they haven't assigned any complex numbers for U and V. So it's your job to just let something equal to, just let it equal to. So in order to do that, well, as you can see, this is where the diagram will come handy. How do I get from V to U? Well, as we can see, U is equal to V cis pi over 3. Yep. Then U squared is, using De Morph's theorem. Okay, so we got that. So U squared is that, plus V squared. So let's see if that is equal to that. Okay, so this is left-hand side. Right-hand side, we got UV, but we know U is this. So V cis pi over 3, and then we got times V. Well, okay, what's 2 pi over 3 as an angle? Okay, cos 60. Hey, this is a half. Oh, it is. Oh, sweet. Okay, all right. I doubted myself. Okay, so they're the same. Yes. Yeah, I was being too afraid. Don't be like me. Just keep going and see where it takes you. All right, cool. That wasn't as bad. Oh, second part's not hard. Okay, just keep in mind, A stands for the area of the triangle. That's what it says in the description of the question. Okay? All right, so we know it's got something to do with the area of the triangle, but with this type of question, you obviously want to work with left-hand side and the right-hand side. Okay, so that means we need expressions for Z. Let's get it in terms of mod arc form because we've got angles involved. So what would Z be? We don't know the modulus either, but do we? Does it say it's... nope. So if that's not given, you've got to actually use that symbol. Okay, that's fine. Then similarly, W is modulus of W. So this is what you want to work with if nothing else is given. And let's just do some algebra work. So I'm just doing this first. So Z that, I need W conjugate. So that means W conjugate. The modulus is still going to be the same, but you're just going to have negative angle. And what do we do with the angles? You add them, but because it's got a minus, it's going to turn out like this. All right. Now let's do the same thing for this, just without the minus. But cis negative theta. So WZ is, so that's WZ. So what do we now got to do with these two? Got to take it away. Take away. As you can see, it's a long expression. So you do want to expand this out into cos and sine form. 2I sine this. It's just all over the place, but that's okay. Right-hand side. Now, we've got to find A. That's our first thing. Area of a non-right triangle is that. So in our case, what do we have? A and B are the moduli of Z and W. Yep. And then you've got the angle in between, which is the, what's that angle? Just that angle. Yeah, phi, that's the letter, yes. Okay, so as you can see, that's just A. So if I now just multiply this whole thing by 4i, it'll just give me that. I'll just write it out just in case. Oh, well, hold on. Oh, wait, I must have missed. Oh, you can't just ignore that. Sorry. Yeah, like, obviously, that's a factor. Yeah, so you can't, sorry, I forgot to. I'll just put it at the end. Yeah? Yeah. Yeah, so that's basically how you do this question. Okay? All right, that's it, done. Complex numbers finished. Proofs next week. Yay. All right, that's